Welcome to monochemistry. In this lesson, I'm going to teach you how to solve a mass-to-mass stoichiometry problem. You need to copy the question down and follow the steps. You'll be bringing your answer to class. So make sure you have a calculator and your periodic table handy. Here's the question. Carbon dioxide that is produced by astronauts can be removed with lithium hydroxide. The reaction produces lithium carbonate and water. An astronaut produces 1,000 grams of CO2 each day. What mass of lithium hydroxide should engineers put on board the spacecraft per astronaut for each day? Don't get it wrong, or you'll kill the astronauts, and that would not be good. For this problem, we're going to assume that there are three significant figures in 1,000 grams. So 1.00 times 10 to the 3 grams would be the right answer, or the right amount for that. And also, we need to note that the products for this reaction are water and lithium carbonate. Let's move on to step 1. Step 1, no matter what we're doing in stoichiometry, is always going to be make sure you have, or to write, a balanced chemical equation for the reaction. Sometimes, as in this question, you'll be given one. I gave it to you. But if it hasn't given you one, then you have to write it yourself. And that's step 1. Step 2 is to write down the mole relationships between all of the reactants and products. When you get good at these, you will no longer have to do this step. But for now, I'd like to see it. So in this particular question, we have 2 moles of lithium to 1 mole of CO2 to 1 mole of lithium carbonate to 1 mole of water. And that is our molar ratio to reactants and products. Step 3 is to find out what information you have been given and what you are trying to solve for. Chances are you've read the question, you've probably already done this. In fact, I recommend as you read the question to highlight or to write down pieces of information that are likely going to help you solve the question. For this particular question, and for all questions involving stoichiometry, I recommend using this method. In the question, it told us we were given 1.00 times 10 to the 3 grams of lithium hydroxide. No, we weren't, Mr. Monahan. In this question, we were told that the astronauts produced 1.00 times 10 to the 3 grams of carbon dioxide per day. And we were asked to find out how many grams of lithium hydroxide would be produced, or should be left on board, to react with the 1.00 times 10 to the 3 grams of carbon dioxide. So this is what we were given, which makes this our known substance, and this is what we're looking for, which makes this our unknown substance. Step 4 is to use the piece of information given in your balanced chemical equation to solve for the unknown. In other words, I'm going to use the 1.00 times 10 to the 3 grams of CO2 to figure out how many grams, or the mass, of lithium hydroxide. Now, just like in the conversions we've done in the past, can I do that in one step? And the answer is not a chance. So, part 4 involves 3 sub-steps. Let's look at those now. Step 4a is to find the moles of the known substance using its molar mass. Well, the known substance is CO2. So I'm going to solve for the moles of CO2. Now I know the mass is 1.00 times 10 to the 3 grams. I'm going to use a conversion factor that I'm not going to give you, and I'm going to solve for the moles. In fact, this is the last piece of information in terms of numbers I'm going to give you. You are going to solve the problem from this point forward. Good luck. I'm going to tell you what the steps are, though, and I'll give you the final answer when you come to class. Step 4b is to use the mole-to-mole ratio given in the balanced equation to convert the moles of the known substance, which in this case is CO2, that you calculated in the previous step, and convert it into moles of the unknown substance, which in this case is lithium hydroxide. Now, in order to do this, you're going to use your mole-to-mole ratio. The mole-to-mole ratio of CO2 to lithium hydroxide is a 1 to 2 ratio, according to the balanced chemical equation. For every 1 mole of this, I need 2 moles of this. So, take your moles of CO2 that you calculated in the previous step and convert it to moles of lithium hydroxide using this relationship. Finally, step 4c, you're going to convert the moles of the unknown substance into the mass of the unknown substance using its molar mass. So now that you know the moles of the lithium hydroxide, I want you to go ahead and convert that into mass of lithium hydroxide. Remember, we do not want to kill these astronauts. We need to make sure we have enough lithium hydroxide on board to react with the carbon dioxide that they're going to produce. You are probably stressed out right now, and you're probably producing a lot of carbon dioxide, but that's okay. We'll make sure we get enough lithium hydroxide to take care of that. That, in a nutshell, is how you solve a mass-to-mass stoichiometry problem, and I look forward to seeing your answers in class tomorrow.